Hi guys, today we're going to be learning about scatter plots, correlation, and correlation coefficients. That's the title of your notes today. So your essential question for this set of notes, how do I create a scatter plot? And then how do I determine the type of correlation and correlation coefficient of the scatter plots? Your scatter plot is a way to represent statistical data that has two variables that you actually usually typically ask two questions about. So you represent your data points as x and y, and then you're going to plot your points on the coordinate plane. So we're going to actually go through and kind of practice plotting those. So as you see here, we're going to practice doing this. So x is the number of siblings, so we're going to say, we're actually going to title this number of siblings. And then our y is the number of pets. So now we're going to label our y-axis the number of pets. Make sure you guys are labeling. See how our graph is already numbered for us. You guys would make sure you would also number your graph there. But now we are going to actually plot some of these points. So that 2 on the first point here is actually your x. So remember, these are all the x's, these are your y's. So 2 is on your x, and you're going to go 0, so this point actually is right at the 2, 0. And then you have 1 on your x, 1 on your y, so you have to go over to the right one, up 1. And then we have another point of 2, 0, which is already there. And then we have 2, 1. Then we have 6, 0, which is over here. And then we have 2, 5. So we're going to go 2, we're going to go up to 5. Okay? So we just create a scatter plot. Our points are kind of all over the place, but that is just how you would create a scatter plot. You're literally just plotting the points. So now, if we talk about our correlation, this is a relationship between the variables in a scatter plot. So we're going to go ahead and draw 4 different scatter plots on how they actually represent things. So our first one here, we are going to just kind of do a bunch of different dots, but kind of in like a positive linear motion. So this one represents a positive value. So now we have our positive, okay, because we could see that our line, if we were to draw a line of best fit, which we'll be learning later, we could see that the line is actually going up in a positive direction. Okay, so now let's do a different value. So if we have positive, that means we will also have negative. So now we have dots kind of going in a negative downward line. Again, if we were to draw that line of best fit, then it would be going down in a negative slope. So now this will represent a negative correlation. And then we have our next one, which we have, which our points are just going to kind of be all like this. So what kind of slope does that actually represent if we were to draw a line? So we see that that line would actually have a slope of 0. So then our correlation here would be 0. We just kind of see that we just kind of base it off the slopes again. And then our last one that we would look at is we would have a cluster all over the place where we aren't really actually able to draw a line. So that actually means that we have no correlation. Okay, so now that we have no correlation, again, it just depends on your line of best fit. Like I said, we'll be learning, practicing those positive slope, negative slope, 0 slope, and then we can't actually draw a slope on this one, so it's no correlation. Okay, so our correlation coefficients now, we're going to have, just going to show you guys kind of a range on how to roughly estimate them right now. So a correlation coefficient is typically used to represent the strength of the actual correlation. So your correlations were at this. We're trying to see how close those dots are and how strong the actual correlation represents. So what I mean by that is if you were asking somebody a question, how many pets do you have versus how many kids do you have? Do you think that there would actually be a correlation there, or do you think that maybe if they had 1 pet, they'd have to have 2 kids? So it's just kind of basing off the question that you guys ask, and you're basing it to see how strong the correlation would actually be, if there is even a correlation. So we always have the numbers from -1 to 1. So if we have our values here, we see that we have our dots, and we're just going to go ahead. I'm going to show you just the -1. So we see that all of our dots are pretty close together, and so this would be r equals -1. If you are at r equals -1, then this is going to be a strong correlation here. Okay. The closer you are to -1, then the stronger you are. Now, if we go to, let's say, like negative r equals -0.05, then we're going to actually see that our dots are kind of scattered a little bit further away from each other. So there's not as close as a correlation. The dots are not directly right on each other, which means that we're kind of having like a moderate to a weak correlation. The closer we are getting to 0, then the weaker we are getting. So let me show you what a correlation of 0 would look like, or our correlation coefficient. So again, if I had like numbers all over the place, then that means that we would have r equals 0, and then this means that we have a weak correlation, or no correlation. So we will be looking at data to see what types of correlations we actually have. And this says correlation, you guys. Okay, so then now we're going to start going to the positive direction. So now if I have a positive 0.05, our dots are going to kind of be a little bit more spread out again, like we saw in the r negative 0.5. So this is going to be 0.5. And then this is going to have the similar one where it's moderate. We'd have a moderate correlation there. And then we'd have our last one where we actually are going to r equaling a positive 1 this time. So remember, if we were to draw our lines of best fits here, we would see that we have a negative slope here, we have a 0 slope here, we don't really have a line going. And then now our numbers are becoming positive at 0.5. And then here, which means we also have to have a positive because it's a positive 1. Our dots are going to be a lot closer together and a lot more of them. And again, if we were to see our line, it would still be a positive correlation. Again, the closer you get to a -1, it's strong, and the closer you get to a positive 1, it is also a strong correlation. So our key point here, -1 to 1, those are the strongest correlations, whether they're negative or positive, and you don't want to go over 1 or -1. All right, you guys, that is it for our set of notes today. I'll see you in class.